Hello everyone, in this video we will discuss about how electromagnetic works in biomedical devices. We choose transcranial magnetic stimulation (TMS) as our selected biomedical device. It is a non-invasive treatment using a magnetic coil to influence the brain's natural activity. TMS is used to treat psychological disorders such as major depressive disorder (MDD), obsessive compulsive disorder (OCD), and migraines. We have different types of TMS such as magnet strength, pulse frequency, pulse pattern, and magnetic coil type and stimulation device.
Okay, so firstly we need to wrap this nail with the copper wire that we have here. Basically like this. Then you need to wrap it fully like this. Okay, after you fully wrap the nail with the copper wire, we need to put it on the positive and negative terminal of the battery. Just make sure that it connect lah properly. Like this also can. This one is the copper. Okay.
Okay.
And now we're going to test it on the thumbtacks and see if it attracts to the nails. So if it attracts, that means there's current flowing through the coil wire and the magnetic fields are created.
Next, I would like to talk about the electromagnetic field theory. In TMS, one of the laws that we use is Faraday's law. TMS rely on the Faraday's law of the electromagnetic induction. This principle states that a change in the magnetic fields within a closed loop induces an electromotive force, EMF, or electric current in the conductor. In TMS, a rapidly changing magnetic fields generated by the TMS coil induce a small electric current in the target brain tissue. Next, the concept in TMS. Transcranial magnetic stimulation (TMS) is an advanced, non-invasive method for stimulating the brain in a awake adult. In TMS, a coil made from a copper winding in the place of the surface of the patient head. During the stimulation, a current pulse flowing through the coil, creating the magnetic fields around it, which excite neurons within the human skull. The unique shape of each individual skull acts as the large resistor, making it challenging to focus the electricity on a specific brain region. Accurate numerical stimulation can support standardization and provide more precise operation. A stimulation coil placed near the surface of the patient head is energized by the short circuit pulse, generating the high intensity, time variant magnetic fields and penetrated nearby tissue, including the skull and brain. According to the differential form of Faraday's law, these time-varying magnetic fields include an electric field depolarized or hyperpolarized neural cell membranes located within the few centimeters of the cortex. When the membrane's potential reaches a certain threshold, an action potential is generated, resulting in macroscopic brain activation in region with a high value of induced electric field. As you can see, this is the equation of Faraday's law that involved in TMS, which is the epsilon naught equal to negative n d phi over dt, which epsilon is equal to electromotive force EMF, n is the number of turn of the coil, and d phi over dt is intentions change of the magnetic flux with time. Next is equation E equal to r dB over dt times r, when r is actually the surface of the region that we take at the patient brain. We also use the other two equation for the Faraday's law.
Application of TMS, Transcranial Magnetic Stimulation (TMS), is a non-invasive neurostimulation technique that involves the implication of the magnetic field to stimulate specific areas of the brain. It's mainly used in the treatment of the various neurological and psychiatric disorders. For today's video, I just want to focus on how it works on depression. TMS on depression. An electromagnetic coil is positioned against the patient's scalp near the forehead to facilitate cortical stimulation. For depression treatment, the focus is on the dorsolateral prefrontal cortex (DRPFC). Repetitive transcranial magnetic stimulation (RTMS) involve delivering pulse in a repetitive that will stimulate the nerve cell in the brain region that associate with the mood regulation and depression. This stimulation promotes neuroplasticity that will leading to the formation of new connections within brain circuits. This treatment will help the patient to restore normal brain activity level.
Hi everyone. For the conclusion part, I am going to talk based on the principles of the electromagnetic field theory and the design of transcranial magnetic stimulation device. From that, we can draw several key conclusions. First of all, TMS has a non-invasive brain stimulation. This device utilizes electromagnetic fields to induce currents in the brain tissue. These currents are generated without physically entering the head, making it a non-invasive method for stimulating specific brain regions. Next, we have spatial targeting. The design of the TMS coil focuses on the magnetic field, allowing for stimulation of specific neural populations involved in various functions. For the third one, we have modulating neural activity. The induced currents in the brain can either excite or inhibit neuronal activity depending on the pulse characteristics and direction of the current. This allows TMS to modulate brain activity for therapeutic or research purposes. Next, we also have the strength and duration relationship between the TMS device. The strength and the duration of the applied magnetic pulse determine the depth and intensity of the neural stimulation. Electromagnetic field theory helps us understand this relationship and design optimal pulse shapes for specific applications. Not forgetting the safety considerations. While generally safe, strong magnetic fields can interact with implanted devices or cause discomfort. Understanding the electromagnetic field theory is crucial for ensuring safe operation and proper targeting within the brain. Overall, TMS offers a powerful tool for neuroscientists and clinicians by leveraging electromagnetic fields to interact with the brain in a controlled manner. Understanding the underlying principles of electromagnetism is essential for the safe and effective use of the TMS technology.